Hi, class. Let's start the chapter. Operation Management, Chapter 3, Demand Forecasting. In this chapter, is we need to identify uses of demand forecast, distinguish between forecasting time frames, describe the common feature of forecast, list the element of a good forecast, and step of forecasting process and contrast different forecasting approach. The whole idea is if we can do a good forecasting, we can minimize the cost and be very effective in the operation also. We will describe at least a three judgmental forecasting method. We'll describe the components of a time series models and explain the averaging technique and solve the typical problems. We also describe the trend forecasting, what's the trend, and solve some typical problems maybe. And we will describe the seasonalities forecasting and during the season, which season, what season is all about, and solve typical using both the central moving average and the annual average methods. Describe associated models, regression models, and solve a typical problem with some regression models. And you saw the video probably about the regression models. Describe the three measures of forecast accuracies and two ways of controlling forecast, and identify the major factor to consider when we choosing a forecasting technique. As we said, in this chapter, we're not going to get deep into calculation and mathematical approach. And the reason there is lots of application now can do these approach as long as you enter the data and ask them what kind of forecasting you're looking for. But here, the outline is what is a forecasting? Um, is there features common to all forecasts? We will see the elements of a good forecast. We will steps to the forecast processing, approaches to forecasting. There's different approaches, and there is a judgmental method, time series method, associative method models, time series models. Um, definitely we need to know the accuracy and the control of forecasts, how we can do the accuracies and control forecasts, and choose a forecasting technique. We're not going to look at the Excel templates during the course. So what's a forecasting? Forecasting is a demand forecast is an estimated of a demand expected over the future period. So estimated demand expected on the future period. And you see the picture here talks about, I see that you get 100 in operation management this semester. She's doing a forecasting for her and he's excited about it. Now, forecasting answers. We looking for answers like how big is the facility do I need to manufacture a new video phones? How much money do I need to run an operation of my accounting office? How many pairs of white shoes should I order for the summer season in my store? How many operators should I schedule next month for my call centers? How much lettuce should I buy for the next week in my restaurant? These are all needed of some kind of a forecasting, and you need a good answers for them too. For example, if you're buying lettuce and stays there, it goes bad. If you're buying shoes, white shoes, and nobody likes it, it stays there as a stock. So you need to forecast demand. You need to look at the demand, you forecast it. Now, three uses for a forecast. First, design the system. You might need a forecast for designing the system, which is it's a long run annual and types of a product and service you want to offer, capacities, equipment, and where is the location you want to looking for. That's a long term, which is you need to forecast the design the system. Then use of the system. Now, after you design it, how you're going to use the system. Now, the medium term, monthly, how much you'll be using, and then inventories is needed, type of inventories, workforce is needed, level of workforce, and the planning production. And then in the short term, which is you schedule the system with the forecasting, daily or weekly, what's amount needed next week or tomorrow, what is amount that needed. Production, purchasing, staff, scheduling, these are all for the daily and weekly forecasting. The feature common to all forecasts, it's a called assumes casual system. What was the past? That's drive the future also. If it's declining, the future is declining. If it's growing, its future is growing. But past is the drive the future. That's a assume casual system. Now, the forecast rarely perfect because of randomness. Because when we do a forecasting, we do a randomness. We will select 5 units from 1,000 or 1,000,000 or whatever. This is a random selection. It could be a bias based or not bias random selection. Now, forecast more accurate for groups because in a group up and down, different color, you can do that forecasting a little bit more accurate, but the individual not much as an accurate. So forecast more accurate for groups versus individual. We need to look at the forecasting for a group as a group or an individual forecasting. Forecast accuracies as a time zone increases. The more you look at the time zone, the horizon of the time zone, the more accurate to it. And what's an element of good forecast? It has to be reliable. Is you can derive a result from some element which is a reliable, should be meaningful, it should be a cost effective and useful time horizons and simple to understand and use. These we will be explaining each one of them. Now, the steps that in the forecasting process, first you want to determine purpose of forecasting. You do these steps also in the marketing research. You do determine purpose of forecasting. You do establish of a horizon time, a time horizon, sorry. You gather and analyze relevant historical data, and then you select a forecasting technique, how you're going to put the data in and prepare the forecast. And then when you prepare the forecast and get the result, you start monitor the forecast. There is what you call a judgmental forecasting. It comes in from your historical and personality type also, which is it's a non-quantitative analysis of subjective input. Considers soft information such as human factors, experience, and gut instincts, historical experience that you have, and knowledge. And then you have what you call a quantitative, which is analyze hard data. And I put you a link to how advanced is analyzing using data now, data engineering. data management, artificial intelligence resulting from these, business intelligence resulting from this. The time series model, which is extended the historical pattern of numerical data. Then you have, so we said the time series model is an extended historical pattern of numerical data. And then you have the associated models, which is a create equation with exploratory variables to predict the future. In the judgmental method, executive opinions, usually, pool of opinion of high-level executive of management. Gartner does that a lot. A long-term strategic or a new product development. You do a Salesforce opinions, which is based on a direct customer contacts, and you speak with them. In the judgmental method, the consumer surveys, you do a Census Canada does that also. There's a questionnaires or focus group, historical analogies, which is use the demand for a similar product, uh, you know, look at them. And then what you have in the judgmental method, the third type is probably the expert opinions, where there is a Delphi method, which is it retrieves the questionnaire circulated until census is reached, or what you call technological forecasting, which is we will look at these, the third one deeper. Now, what is the time series? Time series is a time order sequence of observation taken at a regular interval of time. So it's an hour, you're looking at who's going to buy what. You're focusing on a certain product, a certain time of who's going to walk in the supermarket to pick that product. So the following six patterns could be identified at time series. Time series. It's the level or the average horizon patterns. You can see the trends there, which is a steady upward or downward movement. You look at the seasonalities because it's a time. There's a regular variance related to the time of year or a day. And then you look at the cycle, which is a wave-like variation, lasting more than 1 year. And then when you have irregular variations caused by unusual circumstances, like an earthquake or something like that, not reflective of typical behavior. And then the random variation is a reflective of more social psychology's behavior. And then the random variations, which is residual variation after all other behaviors are accounted for, is called noise. So the random variation is a residual variation after all the behaviors are counted for. We will explain what we did in the Conopa hydro case business in North Manitoba. Did that study for them. Now, in the pattern of a time series, what do we do? We usually have what you call a trend component. Okay, so demand show the snow boats, how much demand is year two, there's more and more and more. And then we have the seasonal peaks, which is in the winter, people have a tendency to buy more. And then where you have the random variation, things that goes out of order like here, and it's not going very normal like we see here. And this is what you call the actual demand, which is actual demand of season and peak. Try to estimate the season peak and the random variation that might happen because of it. Now, in a time series model, it is a naive method, which is use averaging method. which is a moving average. We're not going to talk that much about them in the calculation. Is a weighted moving average, exponential, and smoothing. And the trend model is a linear, as we saw, and could be non-linear, like a U shape or talk shape or whatever, and trend adjusted exponentially smoothing. If you notice, there is a trend happening to purchase more of the same product over time. The techniques for seasonalities, techniques for the cycles, actually, we talked about is like a cycle seasonalities, and in some season is high, some season low. It's like the case of economic booming and recessions. The naive method is says the next period equal with the last period. Simple to use and understand, and very low cost and low accuracy. Just what you bought in the warehouse last period, you're going to put it again in the current period. It's just the same thing. So your forecast equal with the actual A. An example, give me a minute. We sold 250 wheels last week at this guy. Now, next week, we should sell the same. That's a naive way, and this person is naive method with it looks at it with a trend, not without a trend. And the trend is that 2 years ago we sold 50 membership. Last year, see the trend, we last year we sold 75, so this year it's going to be 100. So that's is a naive method with a trend of a growth. Now, moving average, in a statistic, a moving average is a calculation to analyze the data point by creating a series of average different subset of a full data. So it could be here, below, upper, and you find the average. So you do every point an average for it, and you get the average for it. It's also called moving mean. We done the calculation of mean, the whole, you add all the variations, and you divide by the number and get the mean. Or it's also called the rolling mean, and is a type of finite impulse response to filter. Then you have the variation include, could be a simple one as we accumulative, or you look at the weighted forms. So simple is just two up, two down, two up, two down, or accumulative, two up, two down, four up, four down, eight up, or a weight you add all these points and divide it over the forms. Now, a moving average of the last few actual data, as you take them and update each period. You update them each period. You see the growth to the previous data and you update them. It's easy to calculate and understand. There is a now application who does that. But what they do also try to add on a smooth bump, uh, lags behind the changes. So it will tell you, the variation of your forecasting and all these things. You can choose a number of periods, include a fewer data points, so you become more sensitive to the change. If because you're not very accurate to the point, more data point becomes smoother, as no smoother as it comes to smooth bumps, and less responsive. It's the data and you respond to it as a forecasting. Here's what you looks at the graph. Take a look at the graph and try to see how this works. We have the actual sales and we have the moving average forecast, and then we have weighted average, which you see is a pretty close to the actual sales because we have a more smoothing uh, involved in it. Now, there is what you call exponential smoothing, sophisticated weighted moving average. It's a new forecast is based on a previous forecast plus a percentage of difference between the forecast and the previous actual value. As usually between 0 to 1, a range from 0 to 1, what is extra, you know, percentage you need to add to cover the gray zone. That's what you call lower or higher also. It's a subjectively choose a smoothing constant and usually alpha range from 0 to 1. So commonly from 0.05 to 5 half a percent. So if you have 100 consumer comes in, you can multiply it by 1.5 or 1.05 or something between them. And it's a widely used, it's also easy to use and easy to alter the weight from historical data. The new forecast equal with the previous forecast plus a percentage of error or forecast error. Actual forecast is in the error terms. Alpha that you're choosing is a percentage actually that you use that a lot. Says it's around 50, 10% up and down, something like that. So it's like a 50.2, 1 up and down, something like that. Um, Forecast, which is we said is a forecast plus a percentage of error per forecast, which is alpha is weighted on the actual demand. So the demands you said forecasted at 100 last year, but suddenly 120 people showed up. So it's a 1.2 multiply whatever your forecast. So 1 minus is the weighted of a previous forecast. The larger the smooth constant, which is the alpha, the more responsive to your forecast. Because if you're selecting, say, zero point 0.9, so it's a 1.9 is like you forecasting 100, but 190 you are warehousing the product unit. So your closer is as more smooth it is. So if you notice here the period time and the demand, so you're expecting that the actual goes up and down here. So if you are using zero point 0.1, it's not covering as much as zero point 0.4, for example, the blue one. Now, how we choose the alpha? When we do that is when the demand is fairly stable, use a lower value alpha. If we know the demand is 100, 101, or 100 or 99, we use a lower alpha and very stable. And that's not going to change over periods of time. The smooth out random reflections, 1% up and down. When the demand increase or decreasing a lot, use the higher value, so that will give us a more cushion in operating, more responsive to the real changes. Involves the demand, the technique for a trend. Now we talk about a trend is probably 2 years ago we bought two. This year, about 3 years ago, we sold one. 2 years ago, we sold two. This year, we sold four. There is a trend. So that's all about technique. But technique for the trends is involved the development of an equation that describe the trend, presuming the trend is a present of in the data. We realize there is a trend and we can describe the trends, the growth, the decline, the timing, the zones. We look at this trend, the generations, the youngers, the olders. There is some kind of trend is growing. And we look at the historical data to discover if there is a trend exist or not. But the trends overall, it doesn't have to be, uh, a growth. It could be, different shapes. If you notice here, over time, could be a growth curve, could be a polynomial trend. There might be exponential trend. So you need to look at them. They're not only a linear trend. These are what you call here, what you see in non-linear, not straight ones. This is what you call a linear trend. But what you notice is the linear trend line develop a linear best fits among the actual observation of that. That's a linear trend. But then there is a deviations. So this is what you call, the right numbers and the actual observations that we're looking at, the actual observation. And these are the point of line is here. So this amount is the deviation, and we can monitor and see that. Then there is what you call the technique for seasonalities and season variation I don't know, is for the boats, for the bikes, for the snowmobiles. Seasonal variation, regularly repeating wave movement in a series of values that can be tied to recruiting events, weather, or a calendar. Christmas, Hanukkah, I don't know, summer, uh, Victoria Day for fireworks. All these is kind of connected to the recruiting events. Using seasonal relatives. Now, seasonal relative or index is an equal proportion of average or a trend, as we spoke about it, for a season in the uh, multiplicative model. In other words, seasonal relative is of 1.2 is equal with 20% above the average. And you do that when during the lunch hour, the percentage of services in the restaurant, you need to see above the average versus non-hours for the. And then you have the deseasonalities, which is you remove the seasonal component to more clearly to see other component. So you take away the, I don't know, the summertime, and you see the, just to understand what's the base for it, for your operation needed as a product, service, or whatever. And if we divide by seasonal relativity also. And then you have re-seasonal, which is adjust for the forecast of seasonal component. So this is the demand. I need 100 units, but in the summer, I need 100. I need an extra 20 units. I need 2 employees all the year, but during the winter, I need another extra one to help us. So adjust the forecast for seasonal component, multiply by seasonal relatives. It doesn't have to be weather-wise. It could be month-wise, could be day-wise. I need or time-wise, I need on a Monday, one extra help, for example. Then you have what you call a cycle. In this cycle is a different, or kind of it's a wavelength movement, but it's a different because it is also similar to variation, but get a longer, period, like a 2 to 6 years between the peak. It's like, the recession, it goes down, or the housing industries, or the constructions. These are takes 2 to 6 years between them. That's what you call a cycle. Example of cycle variation can be found in the economies of countries where the prior experience times of growth, like inflation followed by recession, slowing down and shrinking the economy. So growth, inflation comes in, recession slowing down and shrinking the economy also. So the associated forecasting, it's about the associative model rely on identification of related variable that can be used to predict values of variable interest. A good example, if two things that you associate with them, although cannot be directly, there could be direct or it could not be directly connected. So like for example, the new housing starts in Canada is related to mortgage rate. So rate as a mortgage rate fluctuate, so does the demand for a new home. You know, the higher the mortgage rate goes in, the less demand for the house. So the lending rates goes down. You notice the demand for homes and housing, and you took that in the micro and macroeconomics too. But how you do this associate models is you put X and Y, X equal with 2Y or whatever the calculation, X equal with a Y plus Z. Now you have the predictable variables. In the predictable variables, if you notice here, X, which is X, is used to predict the values of variable of interest, which is Y, and also called dependent and independent variable. So independent variable is does not grow. The dependent variable, it grows whenever the independent variable grows or shrinks. That's called predictable variables. And then you have what you call the linear regressions, which is comes in from predictable variables, the process of finding a straight linear. We saw it in the previous fourth slide earlier, that the process of finding the straight lines the best fit to the set of opinion. And use the least square equation. So it could be, a little bit higher or lower, something. And then you have the multiple regressions, which is that they use it in a lot, driven from linear regressions, which is a model with a one more than one more predictable. And I said use it a lot in the artificial intelligence driven activities or into data data engineering. And it's a computation is complex and created with the computers. These days we utilize these models a lot. So as you see, the simple linear regression, as the x becomes 5, 7, y 15, and if it's 2, y 10, if it's 6, x is the 13. This is what you computed linear progressions, and it's kind of a straight linear, and it's around that line. We're not going to talk a lot about this, but the coloration and Excel. There is a coloration coefficient, which is range from -1 to 1. If you took it in a statistics course, if you're not going, refresh yourself. And it's a measure of the strength of relationship between two variables. As this increased by 50%, what's the percent of this dependent variable will grow? If this is increased by 5%, it could be this increased by 50% or less by 50%. So the variable comes from -1 to 1 or +1, and -1 is the two variables, and because it's like this, they move together in the same directions, and two variables move together in the opposite direction. Then there is Corel, which is you talk about range of value, Y values versus the range of X values. There's a certain range that cannot go more or less, whether it's Y or X. So Mm, instead of putting -1 and -2, we do the r power 2, which is that makes it a positive, and usually is between 0 and 1. And it's just to see the variations, and the higher value, more useful predictors. And that is what you call a range of values, y values, range of x, y. Accuracy and control of the forecasting process are vital aspect of forecasting. The more you're close to realities, the better for you. So you don't need to bring four manpowers if you need only three. If you're close to a forecast that you only need three, and you're not taking an associated risk, then you're close to forecasting, and you lowering you become more effective and efficient. Forecasting accuracy is a degree of correctness, how correct, of the forecast generated by the forecasting processes that you are using in your forecasting. And the accurate forecasts are necessary to success of daily activities of every organizations. There's lots of example we can bring in this. And inaccurate forecast can result in too few or too many resources, and sometimes you find this was stock or you go loss. Too little or too much output, and that's when you have no option but to sell that very low price to get rid of the stocks that's in your warehouse, or the wrong output, or the whole total thing. Now, there is a forecast error and bias, and you have to keep that into account when you do your calculation. Bias is the sum of forecast error, and when you have 100 peoples and you have to calculate the bias, how many, what's the chance when you're selecting is ones that repeating itself more. So you have a positive bias, which is a frequent underestimations, and then you have the negative bias also, which is a frequent overestimations, which is all that cause errors. The possible source of errors include, it could be not only that, the bias, it could be model may be inadequate, things that have changed, or you select the wrong thing, incorrect use of forecasting techniques that you use, or irregular variation that happened, like we brought the earthquake happens. So we need to control the forecasting process. And to when we do a forecast, we said we're going to monitor the last steps, the 6 steps, and we need to control the forecasting process. It is necessary to monitor forecasting error to ensure that the forecasting process is performing adequately and remain accurate enough. So it's important to see whether we've done the right forecasting. If it's not, we need to correct the action for now and for the future also to take the forecasting properly. And we need to monitor forecast error is we usually accomplished by either a control chart, there is a chart, for example, and we look at the forecasting, whether it's close to that chart, and also could be a tracking signals or whatever. Uh, there's a water, if things how much is going higher or a lower. This is also, we can do a tracking signal, would give you an accurate forecast. You see here, there is what you call a random a range of random variabilities, and the majority is usually at the middle here, which is that's a zero, and then you have the upper limit. No, this is what you call a normal distribution. Majorities is that amount, and there could be lower and higher. And I think this is probably you took it in the statistic, or if you took a marketing research course also. So the forecast error for, see for each period, whether it's upper or lower than the normal distribution of forecast error. And the control chart example, the question comes in, what has happened to our forecast accuracies? There is an upper limit as we put, and there is a lower limit. Is there an identifiable pattern to this forecast? What's causing these errors happening? And we see that it's going down to the mean average. Choosing a forecasting techniques. There is no single techniques work in every situation. Each situation, each demand, each result has a different technique to use. Now, but the most common important factors is cost and accuracy. How accurate you want or how costly you want to be. And other factors in selecting the forecasting technique, availabilities of historical data, whether it's a secondary data or primary data, forecasting horizon time, and the pattern of the data, how you collect them and where you collect them. So in this chapter, we were able to forecast. We know that forecasts are vital for input because they help the managers to anticipate the future and make a decision. Forecasting horizon are classified into a long, medium, and short term. Forecasting techniques can be classified as a judgmental, we spoke about it, or a quantitative. Judgmental methods rely, we said, on the judgment, experience, historical experience, and expertise of executive, sales staff, probably expert, consultant, or consumers to formulate some kind of a forecast. The judgment method include executive opinions, sales forecasts, again, consumers, or some consultant that is involved in that field. And then we talked about the quantitative techniques, use the prices, numerical calculate, precise, I'm sorry, use the precise numerical calculation to develop to develop a forecast. Two major quantitative approach we spoke about at the time series and the associated techniques, which is or the casual techniques. The time series techniques rely on historical data collected, a project past, their pattern and variable in the into the future. Include averaging techniques. We said moving average, exponential. We used terms of moving average and exponentials to make sure it's smoother. And we notice that we look at the linear trend. There's some trends there. At the time series decomposition of seasonal data, we take away the seasonal data like a winter time or a summer time, and we see the basic thing and we see the added part of it. And then you have what you call the associated technique, such as of regressions, attempts used in lots in the database management to explicitly identify influencing factors and to incorporate that information into equation that can be used to predict process. We also did talk about seasonal technique, adapt to our forecast if we have recruiting. We did not touch on MAD, MAP, and MSC. We will do it later on down the chapter, other chapters. And we did the control forecast involved deciding whether a forecast is performing adequately using, for example, a control chart. When selecting a forecasting technique, a manager must choose the technique that will serve the intended purpose at an acceptable level of cost of accuracy. How accurate you want with your budget. This is your budget. Cost and accuracy is always needs to look at each other. So the learning checklist describe the last three judgment forecasting, describe the component of time series, describe the trend forecast and solve the problem, describe the seasonality forecasting, and solve the typical, describe the associated model, and then identify use of demand forecast, distinguish between forecasting time frames. We will describe this to describe the common features of forecast. We looked at the contracts different for forecasting, identify major factors when we're choosing a forecasting techniques, set price and accuracy. This is the end of chapter.